Every spring, a silent migration occurs. Thousands of the world's most expensive assets, superyachts, must transit 3,500 miles of open, unpredictable ocean. But for the owners of these floating palaces, the Great Atlantic Crossing is a logistical nightmare. To sail a 200-foot yacht across the pond is to invite disaster. It means subjecting delicate stabilizers to 20-foot swells. It means 300 hours of continuous engine wear that can wipe $500,000 off a vessel's resale value in a single trip. And it means burning enough diesel to power a small city for a month. The solution isn't found in a faster yacht. It's found in a ship that defies the basic laws of naval architecture. A 700-foot steel titan that can commit intentional sinking to swallow an entire fleet. Today, we're going inside the machine that moves the 1%. This is the story of the MV Yacht Servant, the world's most advanced semi-submersible heavy-lift vessel. A ship that doesn't just carry cargo, it creates a mobile piece of the ocean floor. To understand the Yacht Servant, you have to understand the sheer scale of the engineering challenge. This isn't just a bigger boat, it's a fundamental rethinking of what a heavy-lift vessel can be. Built by the renowned Daman Song Cam shipyard in Vietnam, this vessel is the culmination of decades of evolution in semi-submersible transport, borrowing principles from colossal oil rig carriers and refining them for the delicate, high-stakes world of superyacht logistics. The core problem: how to create a ship that can both sink on command and sail efficiently across thousands of miles of open ocean. The answer lies in a series of radical design choices. First, the sheer dimensions are staggering. At 214 meters long, over 700 feet, she is longer than two Statues of Liberty laid end to end. Her beam, or width, is a colossal 46 meters, providing immense stability. But unlike a traditional cargo ship, the Yacht Servant has no hold. Her entire cargo capacity is concentrated on a single, vast, open platform, a 68,000 square foot expanse of high-tensile steel. This deck is an engineering marvel in itself. Constructed from specialized AH-36 marine-grade steel, chosen for its superior strength-to-weight ratio and performance in low temperatures, it's far more than a simple floor. Beneath the anti-skid surface lies a complex internal lattice of longitudinal girders and transverse frames. This structure is designed to do more than just support the multi-billion-dollar cargo on top. When the vessel submerges, this deck becomes the primary barrier against the crushing hydrostatic pressure of the ocean, resisting thousands of tons of upward force trying to buckle it from below. To achieve this unique semi-submersible capability, Daman abandoned the traditional V-shaped hull used to slice through waves. Instead, the Servant employs a catamaran-inspired sidewall design. Her massive engines, twin Wärtsilä diesel-electric plants generating over 12,000 horsepower, are housed not deep in the hull, but tucked away in these two narrow side casings. This ingenious layout serves two purposes. It maximizes stability, and more importantly, it leaves the entire center of the ship open, creating a float-on, float-off bay that is, in essence, a portable deep-water harbor. That power isn't just for propulsion. The diesel-electric system feeds a sophisticated power grid, driving two main azimuthing thrusters at the stern and powerful bow thrusters for maneuverability. This setup is crucial for the vessel's dynamic positioning, or DP2, system, a computer-controlled network that uses GPS and sensor data to automatically maintain the ship's position and heading with pinpoint accuracy, even in challenging currents and winds. This is vital during the delicate loading operations. But the most critical piece of technology, the system that orchestrates the entire submersion and refloating process, isn't the engines or the thrusters. It's the ballast control system. To intentionally sink a 214-meter vessel, you must first master a fundamental law of physics. Archimedes' principle dictates that an object in water is buoyed by a force equal to the weight of the water it displaces. In its light state, the Yacht Servant is a testament to buoyancy. But to receive its precious cargo, it must defy this principle and become heavier than the 100,000 tons of seawater it will soon displace. This is achieved through a complex and meticulously controlled flooding operation, a process the crew calls the ballast ballet. The ballet begins on the bridge, with the chief engineer at the helm of a sophisticated ballast control system. This isn't a simple case of opening the floodgates. The 76 independent tanks are filled in a precise, pre-calculated sequence. The system models the entire operation, ensuring stability at every stage. Once the sequence is confirmed, the command is given. Massive sea chests, some several square meters in size, open to the ocean. Gravity, the conductor of this orchestra, begins its work, pulling seawater into the ship's lower chambers. As tens of thousands of tons of seawater rush in, the ship's main deck begins its slow, deliberate descent beneath the waves. This is the danger zone. As the vast, flat surface of the deck submerges, the ship loses what naval architects call its primary stability, the natural resistance to rolling, provided by a wide waterplane area. For a terrifying few minutes, the vessel's stability relies almost entirely on the buoyancy of its two thin side walls, turning it into a delicate balancing act on a colossal scale. When you submerge a ship of this size, you are fighting the ocean's urge to capsize you. The single greatest threat is the free surface effect. If a tank is only partially full, the water inside can slosh from side to side, amplifying any small roll. If that sloshing synchronizes across multiple tanks, the ship could roll 90 degrees in seconds. To prevent this, we minimize the number of slack tanks at any one time. The ballast sequence is designed to fill tanks completely before moving to the next, ensuring stability. We monitor the heel, the side-to-side tilt, and trim, the front-to-back tilt, to a fraction of a degree. The system is built with layers of redundancy. Should a valve fail or a pump malfunction, automated safety interlocks halt the process, giving the crew time to respond. But today, the ballet proceeds without a hitch. The gyros remain steady, the bubble level perfectly centered. The deck vanishes, leaving a calm, protected marina where a steel platform once was. The giant is submerged, stable, and ready to welcome its passengers. Once the deck is 9 meters underwater, the Yacht Servant is no longer a ship. It is a submerged dock. Now begins the most expensive game of Tetris on the planet, a puzzle where the pieces are worth billions and the board is a floating steel island. The preparation for this moment began weeks ago. Long before a single yacht approaches, the Loadmaster's team creates a bespoke docking plan for each vessel. Using advanced LiDAR scans and manufacturer blueprints, they generate a precise 3D model of every hull. This digital twin is the key to the entire operation. Because every hull is shaped differently, the ship's deck must be prepared with custom-placed keel blocks, massive towers of timber and steel, some weighing over a ton. The docking plan dictates the exact coordinates for hundreds of these blocks, creating a unique cradle for each yacht. It's a complex grid designed to distribute millions of pounds of pressure safely across the Yacht Servant's reinforced deck. With the deck submerged, divers descend into the murky water of the cargo bay. They are the final arbiters of the plan, working in near-zero visibility. Guided by underwater laser lines and constant communication with the surface team, they make millimeter-perfect adjustments. They must ensure that as the ship rises, each yacht settles onto its blocks with surgical precision. If a $100 million yacht is off by 6 inches, the immense point loads from the hull could crush its own internal plumbing, snap its stabilizer fins, or even compromise the structural integrity of the yacht itself. The margin for error is zero.
It's a high-stress environment. You have 20 different yacht captains, all nervous about their owners' prized possessions, trying to maneuver multi-million-dollar assets in a confined space. They're listening to us, but they're also listening to their boss on the phone. Our job is to orchestrate the entire ballet. We direct them one by one, managing their approach speed, their lines, their position relative to the other vessels. We are the calm in the center of that storm, the single source of truth in a sea of competing priorities.
Once all yachts are in position and tethered, the final command is given. The deballasting sequence begins. As the deck rises, the yachts are captured. The water drains away in powerful torrents, and for the first time in months, these ocean-going vessels are high and dry, perched on a steel island 20 feet above the sea. The game of Tetris is complete. A single spot on this ship can cost upwards of $1 million. For that price, you could buy a small fleet of luxury cars. So why do billionaires pay it? Because the hidden costs of sailing solo are even higher. Then there is the carbon delta. By grouping 20 vessels onto a single, highly efficient hull, the Yacht Servant achieves a massive economy of scale. Our proprietary data shows that piggybacking reduces the carbon footprint of a transatlantic transit by a staggering 82%. In an era where green shipping is no longer optional, the semi-submersible is the only way to move a luxury fleet sustainably. Most people see a superyacht and see a symbol of excess, but when you look closer, you see a masterpiece of maritime logistics. The Yacht Servant and her sisters are the invisible backbone of the luxury world. They are the giants that allow the world's most delicate treasures to travel the globe without ever moving an inch. Massive power, surgical precision, and the ability to vanish on command. That is the secret of the Superyacht Piggyback. This is Global Arteries.